Good day everyone. Welcome back to our second discussion on Earth science. Today, we will now fly to our own planet Earth. We will be dealing with the Earth's spheres, its structures and also its interactions. Earth is the only planet in the solar system capable of supporting life. Complex and brilliant combination of gases, composition and structure of Earth are some of the reasons why it can sustain life. Earth is a very complex place. The name Earth is at least 1,000 years old. All of the planets, except for Earth, were named after Greek and Roman gods and goddesses. However, the name Earth is a Germanic word, which simply means the ground. The Greek equivalent to Earth is Gaia, Terra Mater, Mother Earth, and Roman equivalent was Tellus, the fertile soil. The Earth consists of 4 distinct yet connected spheres. All of the processes on Earth are driven by 4 spheres, which we describe individually, but are really all connected. So what are these different spheres? On the image we see the following key elements that represents Earth mainly: air, water, and land. These key elements comprises of what is Earth today and even in the past and also in the future. And because of these key elements, our Earth won't be the Earth as we see it and observe today. Now, we will be talking mainly about these following spheres: the atmosphere, geosphere, hydrosphere and biosphere. And all of these spheres are part of the Earth system. The atmosphere is the part of the Earth system that includes the mixture of gases that surrounds the planet. The geosphere is the part of which includes the internal layers of the Earth, which are the crust, mantle and the core. The hydrosphere on the other hand is the part on which talks about the planet's water, including the surface waters, groundwater, ice, salt water and water vapor. Lastly, we have the biosphere that includes all the living things including plants, animals and other organisms. Alright, let's discover these spheres one by one. Let's start with the geosphere. The geosphere describes all of the rocks, minerals and ground that are found on and in Earth. The geosphere is divided into 3 main parts: the crust, mantle, and core. This includes all of the mountains on the surface, as well as all of the liquid rock in the mantle below us and the minerals and metals of the outer and inner core. The continents, the ocean floor, all of the rocks on the surface, and all of the sand in the deserts are all considered part of the geosphere. Basically, if it looks like solid ground, it's part of the ground sphere. This time let's recall the internal layers of the Earth, or basically its inner structure. The planet Earth is made up of different layers: the very thin, brittle crust, the mantle, and the core. The mantle and core are each divided into 2 parts. Although the core and mantle are about equal in thickness, the core actually forms only 15% of the Earth's volume, whereas the mantle occupies 84%. The crust makes up the remaining 1%. We also have the Gutenberg discontinuity that boundaries the outer core from the lower mantle, and the Mohorovičić discontinuity, or what we call MOHO, that boundaries also the upper mantle and the crust. What's making it more interesting is that each of these layers has its own different physical characteristics and composition. Layers on the left side of the table are based on the differences in composition of each layers, of which the crust is composed primarily of silica plus light metallic elements. As you go below, it will still be made of silica, but iron and magnesium will now be present. And lastly, the core is made up of iron and nickel. On the other side of the table are its mechanical or physical characteristics. We can observe that the lithosphere is composed of brittle solid part, and underneath it is a plastic, a solid yet nearly liquid, asthenosphere. The lower mantle, historically known as the mesosphere, is composed of a solid structure. As we go inside, we will meet the outer core that is in liquid state and the inner core that is a solid one. Again, the geosphere is the sphere that is mostly solid and the rocky part of the Earth that includes volcanoes, rocks, minerals, coal, oil and the land itself. From the surface we have the crust that is a thin, outermost layer that is made of silicate minerals. The crust is the outermost part of the Earth and is very thin compared to the other layers. It is a part where the living organisms dwell in. It forms a very thin continuous layer that extends underneath the ocean and continents. That is why we have two types of crust, the oceanic that is 5 to 10 kilometers thick and the continental crust that is 35 to 70 kilometers thick. The continental crust is mostly composed of different types of granites, a type of rock. Geologists often refer to the rocks of the continental crust as Cl, which stands for silicate and aluminum, the most abundant minerals in continental crust. On the other hand, we have the oceanic crust, which is mostly composed of different types of basalts. Rocks of the oceanic crust are referred to as sima, which stands for silicate and magnesium, the most abundant minerals in oceanic crust. And the oldest of which are called cratons, and it is the most stable part of the continental lithosphere that are found deep in the interior of most continents. We'll jump now to the mantle. This is the part of the Earth that is the mostly solid bulk of Earth's interior that is made of very slow-flowing, solid rock consisting of silicate minerals that are denser than in the crust. The mantle lies between Earth's dense, superheated core and its thin outer layer, the crust. It is made up of silicates, magnesium oxide, iron, aluminum, calcium, sodium, and potassium. The mantle is divided into two layers, the upper mantle and the lower mantle. Earth's crust floats on the mantle much as a piece of wood floats on water. The slow motion of rock in the mantle shuffles continents around and causes earthquakes, volcanoes and the formation of mountain ranges. Below the mantle is the Earth's core that is about 7,100 kilometers wide and 3,500 kilometers in radius, which is the dense center and hottest part of Earth. The core is made almost entirely of iron and nickel. The outer core is the liquid layer of 2,260 kilometers thick. The core is responsible for the planet's magnetic field, which helps to deflect harmful charged particles shot from the sun. And it is in this layer that we can find the movement of metallic iron that generates Earth's magnetic field. The inner core also is a hot, dense ball of iron. The temperature of the inner core is far above the melting point of iron. Despite its higher temperature, the iron in the inner core is solid due to the immense pressures that exist in the center of the planet. So what are the roles of the geosphere? What does it contribute to the Earth system as a whole? The geosphere is very important since it is the contributor of particulate matter and atmospheric gases to the atmosphere and also a contributor of salts to the ocean to maintain its salinity. Also, it is the ultimate source of nutrients for all living things. Because our plates are moving, the geosphere produces barriers that aid in the isolation of population of organism, therefore influences evolution. Planet Earth has been called the blue planet due to the abundant water on its surface. Over 71% of the surface area of the Earth is covered by water. All the Earth's water, solid or in liquid form, those that are contained in glaciers, rocks, soil and the air, comprise the Earth's hydrosphere. By its definition, the hydrosphere is the part of Earth that is liquid water. About 97% of Earth's water exists as salt water, while the remaining 3% is freshwater contained in glaciers, lakes and rivers, and beneath Earth's surface as groundwater. Only a fraction of Earth's total amount of freshwater is in lakes and rivers. Water on Earth is constantly moving. It even moves into and out of living things, like we need water to live and we excrete it afterwards. When we say about the water is moving, we are talking mainly about the hydrologic cycle. Water on Earth is continuously moving. It endlessly circulating through the hydrologic cycle. As water goes in a cycle, it changes its states. From liquid to ice to gas and back again. Sun heats water, causing the water to evaporate. Rising air currents take the water vapor up in the atmosphere. The vapor rises into the air where cooler temperatures cause it to condense into clouds. Air currents move the cloud. Cloud particles collide, grow, and fall out of the sky as precipitation. Most of the precipitation return to the oceans. And because of this water cycle, it generates the different sources of water here on Earth that includes the surface water and the groundwater. Surface water includes the ocean as well as water from lakes, rivers and creeks, while the groundwater includes water trapped in the soil, and we have also frozen water that is trapped in the ice caps and glaciers. Only 3% of the water distribution are freshwater, while 97% of which are salt water. That's why we need to conserve every water that we will use in order to sustain humanity. Same with the geosphere. The hydrosphere also is vital and important since it is the one who moderates every climate on Earth. It also transfers heat and energy. Living organisms also need water to transport nutrients and waste in order to survive. Water overall is essential in many of the Earth's processes, from mineral formation below the ground to everything that it touches on the surface. We have the third one, and that is the atmosphere. This is a very huge envelope of air that surrounds the Earth and pulled by the gravitational force of the Earth. The Earth's atmosphere is primarily composed of 78% nitrogen and 21% of oxygen. Other gases like argon, carbon dioxide, carbon monoxide, ozone, hydrogen, helium and other inert gases make up the remaining 1%. Earth's atmosphere provides oxygen for living things, protects Earth's inhabitants from harmful radiation from the sun, and helps to keep the planet at a temperature suitable for life since it traps some energy from the sun, which helps keep Earth warm enough for living things to survive and multiply. Some gases of the atmosphere absorb and reflect harmful ultraviolet (UV) rays from the sun, protecting Earth and its living things. The atmosphere also causes space debris to burn up before reaching Earth's surface and causing harm, so basically it is a defense barrier mechanism that protects us from visitors outside. The atmosphere reaches over 350 miles up from the surface of the Earth. It is made up of different layers as shown in the image. The lowest layer is what we call the troposphere, from the word tropo meaning change, thus it is the part of the atmosphere on where there is weather and there are changes in the atmosphere itself. This is the part on which air is closest to Earth. This is the area on which we live and where weather is formed. Airplanes and other aircrafts fly at the top of it. It is located 0 to 10 kilometers from the ground surfaces. The next layer is the stratosphere, from the word strato meaning layer or level. This layer lies above the Earth's weather and mostly changes very little. It contains the ozone layer, which shields us from the sun's ultraviolet radiation except where it's been harmed by man-made chemicals. Above the stratosphere we can find the mesosphere. This is the coldest layer and meteorites break apart here. This is where diffused atmospheric components are found. Thermosphere, the next layer, lies above mesosphere. It is 5 times as deep as all other layers combined, and it is a very hot layer that holds up to 2000 degrees Celsius because as you go farther away from the ground the atmosphere will become thinner. Lastly, we have the exosphere, from the word exo meaning outside. This is the part where satellites circle the Earth, and this is beyond 300 miles above the surface of the Earth. Like the geosphere and hydrosphere, the atmosphere serves as a barrier that protects the Earth from outside visitors. It acts like a shield that disintegrates every object that is coming inside of the planet. One thing is that, it contains the gases that living things need for survival. For example, carbon dioxide for photosynthesis and oxygen for respiration. It also transfers heat that is coming from the sun. The ozone layer that is found on the stratosphere protects living things from excess harmful ultraviolet radiation. Lastly, it plays a part in weathering and erosion on the surface of the Earth. The least we don't forget is the part on which life is located. We have the biosphere. The biosphere is where all forms of life exist. Since life exists in the air, in water and on the ground, its boundaries overlap other sphere, because life can be found everywhere on Earth. The biosphere is sometimes thought of as one large ecosystem, a complex community of living and non-living things functioning as a single unit. It includes all organisms on Earth as well as the environments in which they live. Most organisms live within a few meters of Earth's surface, but some exist deep beneath the ocean's surface, and others live high atop Earth's mountains. All of Earth's life forms require interaction with at least one of the other systems for their survival. Because of this, the biosphere is structured into a hierarchy known as a food chain on which energy and nutrients, like carbon, are transferred from one level of the food chain to the next. Here in the biosphere, it aids in weathering and an important sink for certain elements, especially carbon. It also mediates the formation of some minerals, and processes like photosynthesis maintains the oxygen content of the atmosphere for the living things to survive. In the smallest sense, we can call the biosphere as our home. Now, we will tackle more of its interactions from one sphere to another, like what we have always been doing on the social media. We humans, on the other hand, are communicating with each other around the globe through technology. We are likely connected through the internet and other social media applications like Facebook, Google, and YouTube. It is more likely the same as what we are doing right now, since I am communicating with all of you and discussing you things about the Earth. The Earth also has its own way of communicating itself. It's not just us humans, but everything here on Earth works hand in hand. Everything is being connected with each other so that it will be in equilibrium and for it to have the balance to sustain the planet itself. Likewise, the four major spheres on Earth are governed by series of processes that are interconnected, and it plays a vital role to make planet Earth work as a whole. With all these spheres that interact with our planet, we can conclude that our own planet is a complex system made of living and non-living things, and matter and energy continuously cycle through the smaller systems. The Earth system is all of the matter, energy, and processes within Earth's boundary, and these are groups of related objects or parts that work together to form a whole. Which means it cannot stand alone, and it needs the other sphere to make the others work. In short, all of these spheres are interconnected, and it acts like a clockwork. Now, let's try to relate it with the present. Why is it called as a system? Let's try to analyze it by this scenario. Now I have a picture of a snake plant. These are the variables that makes it alive. We have sunlight, land, water, and air. What if there will be a lacking variable? Will the plant survive? Of course, it won't, since it needs those variables to grow. As you can see, a plant that lacks any variable will not survive. Thus, it needs the primary elements for it to survive. So basically, everything is connected and acts like a system that works together to form a whole. This time we will picture our Earth as one whole working body, since it works in a systematic way. The Earth system is all of the matter, energy, and processes within Earth's boundary that continuously cycle through the smaller systems. When we talk about a system, it means that a group of related objects or parts that work together to form a whole. For example, working with your group mates in an activity. You are working with each other to accomplish something, and that reflects our Earth. All of the spheres of Earth interact as matter and energy change and cycle through the system. A result of these interactions is that they make life on Earth possible. Earth's spheres interact as matter moves between them. In some processes, matter moves through several spheres. The main source of energy then comes from our sun, and we have also the internal heat that is given off by the planet itself. Let's try to have some examples that deals with system interactions that can be related to our environment. This is an actual photo taken during the eruption of Mount Pinatubo on June 15, 1991. As we can see, the eruption is being generated in the geosphere. And in this case, Mount Pinatubo is releasing huge clouds of volcanic ash and gas that rises above its crater, and the eruption is considered the second largest volcanic eruption on Earth in this century. Here, we can observe that the geosphere is generating the event and it has adverse effects to the atmosphere and the biosphere, for which it can displace the living things living on the vicinity of the volcano, and also it can affect the health of people and animals that can lead to death. Moreover, it can also affect the atmosphere since it is giving off mixture of gases and dust, making the whole Earth's temperature to lower down. We have also earthquakes, one of which is the Bohol earthquake that happened in the year 2013. The event, like the volcanic eruption, originates in the geosphere because of the movement of the plates below the surface of the Earth, when in fact the Philippines is primarily located in the Pacific Ring of Fire, meaning it is an earthquake-prone country. Earthquakes can damage buildings which may kill people in the biosphere. It can also cause fires which releases gases into the atmosphere. Moreover, the destroyed buildings can be a source of noise pollution and dust pollution that affects everything in the atmosphere and can also be a problem to the people living in the area. Earthquakes can also induce and may cause a tsunami if it will happen in the hydrosphere, specifically on our seas and oceans, that can eventually hit land and kill both animals and people. Lastly, we have typhoons. This is known in the Philippines as Super Typhoon Yolanda. It was one of the most powerful tropical cyclones ever recorded. On making landfall, Typhoon Yolanda devastated portions of Southeast Asia, particularly the Philippines. Unlike the earthquakes and volcanic eruptions, a typhoon originates in the atmosphere and collects energy from the hydrosphere through the oceans. These winds then collect moisture and rise, while colder air moves in below. This creates pressure, which causes the winds to move very quickly. The winds rotate, or spin, around a center called an eye and eventually devastates everything in its path. Since it can destroy everything in its way, it can be a problem to the people living in its vicinity. It can affect also the hydrosphere since it can create storm surges and can also induce floods. It can also affect the geosphere, for it can create landslides. After seeing everything that we have discussed, we can conclude that everything around us is connected to one another. For example, many birds biosphere fly through the air atmosphere, while water hydrosphere often flows through the soil geosphere. In fact, the spheres are so closely connected that a change in one sphere often results in a change in one or more of the other spheres. One small problem can lead into other big problems and will turn out just like a domino effect. With this, we learned that the four spheres, namely geosphere, atmosphere, hydrosphere and the biosphere of Earth, drive all of its processes and support life on our unique planet. Material on Earth doesn't stay how it is. It gets recycled into other phases and forms. Plants in the ground die, and as they are broken down by microorganisms, they become soil, which can then feed new plants. Water cycles through different phases and locations, like when it evaporates from the oceans and then rains down onto the ground or into a lake. Rock also gets recycled under Earth's surface, where it is melted down and then sent back up in volcanic eruptions. I hope that you have learned something from the discussion. See you on the next video.